Circular orbit. For an object in circular orbit, the orbital speed is inversely proportional to the square root of the orbital radius. This equation comes from setting our two f's equal to each other. Remember, f can always equal f, any f. In this case, if the gravitational force is the only force acting on an object in a circular orbit, we would set that equal to the centripetal force. So we have gmm over r squared equals m times v squared over r. Solving for v, we get this equation. For an object in circular orbit, the square root of the orbital period is directly proportional to the cube of the orbital radius. We did the same thing, but this time instead of using v, we used the distance that we traveled over the time that it took, which the distance that we travel whenever we're going in a circle is 2 pi r, and the time that it takes to make one complete revolution or one complete cycle is called the period. This is Kepler's third law of planetary motion. Newton's law of universal gravitation explains how planets and satellites move. Astronauts in space feel apparent weightlessness because their acceleration is the same as the spacecraft they are in. The astronauts in the International Space Station are falling towards Earth at the same exact rate that the International Space Station is falling towards Earth, so they don't feel like there's any gravity. Yes, there is gravity in space.